Hey guys, so a couple weeks back we did a Rotary Jig live stream where we set up a Rotary Jig and showed people how to use it on the new beta version of Lightburn, and we got a lot of questions, and I mean a lot of questions, about different ways to set it up and different ways to use it, and if it works with EasyCAD and when it'll be out for Lightburn. We don't know when it'll be out for Lightburn just yet, it's still in beta, but figured I'd get a guide out there for everybody on creating a jig, implementing some of the tips and feedback that we got, fixing some of the mistakes that I made on live stream, and show people how to use it on EasyCAD until it is available on Lightburn. So we're gonna go over that all today, and we're gonna get started right now. Okay, everybody, so we're going to be starting off by making a rotary jig. Now, you could do this for anything from business cards to slate coasters to anything. I mean, pens. You could use this for just about anything. The key to this is optimizing bulk workflow. So if you have a lot of the same object to do, you can load up a lot of them on a jig and have the laser do the work for you. So all you have to worry about is loading and unloading. And the benefit there is you can do less unloading and unloading because you're doing multiples. It's a really big efficiency tool, and that's a lot of the reason why there's a lot of hype around it. So I just want to start with that. What I'm going to discuss is a general broad spectrum overview of what you can do with this. It's certainly not a limiting description here. So if you can imagine it, you can probably set it up to work with it. So let's just dive in. So first thing we're going to do is you're going to need a measurement on one of the teeth of your rotary. Basically, when you're looking at your rotary, there's usually 3 or 4 jaws. So the measurements of mine are going to be about 12 millimeters wide, and I'm aiming for the second tooth on the rotary. So I'm going to make it about 28 millimeters, and that gives me enough room where I can slide the jig into the rotary and have some room to tighten and loosen the jaws. And that third tooth on my rotary is going to be there to support the jig from underneath, give it a little more stability. So I'm going to go ahead and start with that. And let's go ahead and make a square. And we're going to go 12 by 28 millimeters. Now, this is just one jaw of my 3-jaw rotary. So I need to add to this a little bit. So obviously I need it to be in the sizing and orientation for the jaw to fit into it. So what we're going to do is we're going to utilize a circle here on the toolpath layer using T1 down here. And I'm going to center these two. And what that's going to do is this is now centralized on the axis where the top tooth is going to be. And now we need 2 more teeth, right? So what we're going to do is make this smaller. This is too big. So let's drop this down to maybe 75 millimeters. Make sure this is centered again. Now you can move up so that it's in this orientation, or you can go down. It doesn't really matter. You could also alternatively center it this way, and it can be the left or the right. Now, it doesn't matter. The key point is going to be the same here, where as long as it's centered in the direction that you're using it, so you want this to be horizontally centered if you're going with this orientation, or vertically if you're going up and down with it, it'll work either way. Now, what we're going to do is I'm going to select our jig hole, or our chuck tooth hole here, and then I'm going to highlight the circle, and I'm going to use this circular array tool here on the left. Now, the benefit of selecting them in that orientation is it's going to use the center of this circle, because it was the last object we selected, as the center point. So previously in the live stream that I did, I used the center of the workspace because I knew if I was using the center of the workspace, I would know the center point. I could type that in manually and I wouldn't need to use this center finding circle here. Well, now you have a second way of doing that. So by doing this into copies of 3, now you have a 3-chuck pattern here that you can utilize for the center of your jig. If you have a 4-chuck, simply go up to 4. That's the gist of it. You want to make sure the start is 0 and the end is 360. Can you use other values here? Maybe, but you essentially want to make sure you have a full circle. That way your measurements come out accurately when you're trying to fit it to your rotary. So the step is simply how many of these items are fitting into a 360-degree circle and what the angle increment would be. This is irrelevant because this is going to change depending on how many copies you do. It's going to impact that automatically, so you don't have to worry about it. One other tip I'll provide here is you don't want these too close to the center. So you'll notice there's a bit of a gap here in between the holes for the cutout for my chuck, and that's intentional. You want to make sure that there's space there so that there's something supporting it from the outside, at least with this type of pattern. I'm going to go ahead and click OK here because we're use last selected object position as center. That's the benefit of the method I just showed you. And rotate object copies is important as well, because if we didn't do that, it would positionally be correct, but it wouldn't be orientationally correct. So we need to use that. We don't need to worry about auto increment variable text here because we're not using variable text. So that's it for this tool in this circumstance. We're just going to click OK. Now, just for argument's sake, we could simply use a circle for the rotary jig and do just a cutout like so. And we can use that circle to work with the jig. That may work okay for some, and you'll have to go on a case-by-case basis for that. In the case of mine, the outer edges of my rotary chuck teeth are actually squared off. So I find that trying to dig them into a circle, it's going to start to create inconsistencies and eat away at my jig a bit. So I don't necessarily want to do that, and I don't want to introduce a variable of the jig shifting around because it wasn't centered. So you'll have to judge whether or not one method will be better for you than another. That said, this is all you need for the center of your jig, and this is the alternative method that may work for you depending on the type of rotary you're using. Just something to keep in mind while we move forward here. I'm going to go ahead and delete this one and move forward with the first design we had here, and let's keep going. So in my case, I'm going to create a slate jig. Now, the slate that I receive and I buy, at least most of the ones that I see for sale too, are mostly 4" by 4" square or 4" circle rounds, which equates to about 100 millimeters once you account for the edges and stuff. Now, what I'm going to do here is we're going to go ahead and make a 100 millimeter square. Easy as that. And this is going to be the cutout for my item that I want to engrave. Now, I'm going to group the center of my rotary here so that it's one item, and I'm going to center all of my objects here in a horizontal plane. Now, what this is going to do is it's going to orient this perfectly so that the center of this square is lined up to the center of this jig. And that way, what I can do is I can select this, and I can select this, and I can now use the circular array tool again. And it's going to utilize the center of that circle once again as the center point for this jig. Now, this is a little bit big. We don't need it or necessarily want it this spread out. So seeing how that turned out, I know I want to bring that in now. So let's try it again. We're going to grab this and we're going to circular array tool. We want 4 copies. That's looking a little better. I could go with this, but I also want to make sure that I'm utilizing my space efficiently. I don't need it to be that big. Again here, the wider your jig and the more weight is on it, the easier it's going to tip over when you take a piece off if it's not bolted down. And this is going to be big enough where I'm going to be working off the side of my breadboard or my work table here. So I want to make this a touch smaller so that the weight is more centralized and it takes up a little less space for storage, and I can cut it easier on my CO2. So that may be a consideration for you as well. So just sharing my train of thought here. So we're going to move it in just a hair more. Back up to 4 copies. That's looking much better. Again, same kind of settings here. We're kind of skipping and glazing over a lot of this because we're leaving it kind of as default for what it fills in as. When we set this to 4 copies, this is automatically going to set to steps of 90 degrees because that's the even step count when you divide 360 by 4. And the other piece of that is, again, use last object position as center is very important here because it's utilizing that circle that we selected last as our center point, so the objects are rotating around that circle. Super important for ease, at least. I'm sure there's a way you could make it work without doing that, but at least for my purposes, I highly recommend it. That way, all you have to worry about is lining up that first item. And once that first item is lined up, if you're using the rotary jig properly, all the preceding items are going to line up in that same spot. So we're going to move forward with that. I'm going to click OK. And we now have the base of a slate rotary jig. Now, what I'm going to do is I'm going to go back here and make a circle on my toolpath again. It's going to be a cut layer, but I'm using this just for visual purposes. This is now going to be the outline of the outside of my jig. So essentially we want to go ahead and make sure that the outer shape here is small enough to fit on whatever machine we're going to be cutting this jig out with. Now ideally you'll be cutting this out on some type of a gantry setup because galvos aren't exactly ideal for cutting. So what I would recommend is doing this on either a CO2 or a diode gantry laser, or if you're lucky enough to have a fiber laser, you could do it on that too if you're really fancy. I've known people to even utilize the same method for doing CNC cutouts. So just a little tip there. Now that I know this is a good size for me and I have material that fits this, I'm gonna go ahead and keep going here. So we have our cutout layers. We do not want to cut out this center toolpath, so we want to make sure that stays. And we do want to cut out these squares for the chuck teeth. Now, you might be thinking, cool, all done, right? Not exactly. So this is going to be a 2-layer design. So what we're going to do, or what I'm going to do here, is I'm going to copy this whole thing over. And we now have a second copy. And you might be asking, why would you want to do that? Save on material. Well, funny thing is, we're cutting out a circle here, so there won't be anything below it to support what we want to do. So if I try and put a piece of slate into this right now, after cutting it, the slate piece is going to fall straight through the jig. So not really useful to us at that point. So we need to cut out, or remove, I should say. We need to remove the cutouts off of our second copy here. So this is going to functionally act as our base layer, and then we are going to put this layer, when we cut it out, on top of it. So if we center these up, perfect fit, and essentially the bottom layer is now on the left, but it's going to function as a catch layer. It's going to hold the things we're engraving from underneath, and the layer on top is going to act as an alignment layer. It's going to hold the slate in position, essentially, or whatever we're engraving. So you could do this with lighters, you could do this with pens, you could do this with pencils, you could do this with many, many different things. So another tip that I have is you can also engrave on it a title. So maybe you don't necessarily know what this is going to be if it sits in a corner for a month, and when you're cleaning out your shop, you don't necessarily want to throw it away if it has a purpose, right? So I'm going to go ahead and call this my Slate Rotary Jig. And we can go ahead and rotate this, and we can use this blue dot here to add a little curvature. Yeah, it's a little too much, but just to kind of dress it up a little bit, right? And let's drop that onto another layer so this can be engraved on. Another thing that you could do is you can also add an angle of increment if you so desired. So perhaps some of us get into the workflow of getting jobs done quickly and rushing through stuff and doing things out of habit, and maybe we need a little reminder to avoid making a mistake, right? So in this case, another thing that you could add is an angle of increment as a reminder to what this is. So what you can do is just kind of throw this in there. So again, not a requirement. This is all just kind of, being extra, but at least in Lightburn, this can be relevant. It's not required, and we'll talk about EasyCAD as well at the end here, but it's a nicety. So anyways, I'm gonna skip that for now. We'll leave the title on there, and essentially this is ready to cut. So pick out your material, set your cut settings and your engrave settings, and that'll be that. I'm going to be proceeding with cutting this out on fiber hardboard, or in some places it's called backer board. I just get it in 4x8 sheets for like $15, so it makes it really affordable and hardy material to make jigs out of. It holds up better than 1/4-inch plywood in terms of warpage and stuff. It's a lot more shelf stable as long as you keep it laying flat. So that's what I use. Again, I've tested this out using cardboard or any material. So if you have a lot of cardboard and you're doing something really light, such as pens or pencils, and you're doing this on like a CO2 galvo, you could totally do that with cardboard. Just another factor to keep in mind is the flammability of the material you're using. So this material is also a little bit more hardy. It would take a lot to ignite, whereas cardboard does not take a lot to ignite. So an awareness of the materials you're using is also another factor to consider here that I think is a valid thing to bring up here. So keep that in mind. I'm going to go ahead and apply my cut settings. All right, so now that we have the design set up and ready to engrave and cut out, I'm gonna go ahead and send this over to my CO2 laser and get it cut out. Once that's done, we'll come back. We'll talk about utilizing this jig that we just made in Lightburn using the repeat marking tool that they just got set up in beta. So in the future, once it's ready for public release, you have that to go back to for knowledge. And then we're also going to talk about how to utilize the same jig in EasyCAD 2, so that if in the meantime you're still using EasyCAD 2, or you want to utilize something like this and you want to bounce back and forth between Lightburn and EasyCAD, or you're still stuck on EasyCAD, you have this to fall back to. So we'll talk about both options here and see you in just a minute. All right, guys, so we're all done cutting it out and we have our base layer and our cutout layer. So with these two, obviously, we want to be able to sandwich these up so that we have two stacked layers. We also want to make sure that the lines in the center are actually lined up. What I would recommend doing in this case is I recommend putting this layer down on the rotary so that it's oriented up, and you can apply glue to the back side of this one and put it down, and utilizing those teeth to align the two layers. At least that's what I do, and I've had pretty good luck. You just want to make sure that when you're applying glue or anything like that, if you're using the rotary chuck to align the two layers so that they're sticking together in the proper orientation to work together, that you're not applying so much glue in the center that the rotary jig sticks to the chuck. That would be problematic, of course. So don't do that. Another thing you can do is you can utilize the cutouts from the jig itself, and you can use those as a key to align them while you're placing them together and gluing and clamping them together. Once they're clamped, remove them and make sure that there's no glue gumming up on the inside of those chuck cutouts. And yeah, that's the only tip I got for you there. I've already also gone ahead and tested and made sure that my jigs fit into the square before I apply any more work to it. I'd recommend doing that just to make sure you got the cutouts to scale the way you need it and everything. But now we're going to go ahead and skip to using the rotary jigs that we just made. At this point, I don't have mine glued together. Mine will work just the same. Depending on what you're using, that may be okay for you too, or you can glue it. In the future, I'll glue it. For now, let's jump into the next part of the project. All right, guys, so here we are back in Lightburn. I have my CO2 Galvo loaded up, and I have the designs I'm going to use. And just a tip I have for kind of getting framed up and set up. What I'm going to go ahead and do is use a toolpath to kind of get lined up with my engrave. So if you're doing something square, and if you set it to the 100 by 100 size of your cutout on your jig, or whatever you're utilizing in this case, and center that up to your work area, I'm working with a 110 lens here, you can utilize the frame function to square it up to the cutout in the jig. Once you get that squared up, you're now squared up. You don't have to worry about anything shifting around, because when you're engraving, as long as you have the steps per rotation set properly for the driver and the machine and the chuck, all you need to worry about is the angle of rotation. And if those two values are set, every time it rotates, it's going to rotate to the next cutout. So in terms of alignment, you only have to worry about aligning the first one. So what I'm going to do, I have that toolpath set now, and I'm just going to go ahead and grab one of my designs and center it up to my work area. And I'm using Mark Select here so that I can have any of the other items that I plan on engraving here off to the side. I can just shift them in as needed. And then this way, if I'm doing a batch run, it just makes it a lot easier, a lot more efficient, especially if the person being engraved for comes back for more of the same thing. It makes things worlds easier to have everything in one spot in one file. So I can just go ahead and save this for one person. I'm going to go ahead and get framed up and get ready to go. Okay, so now that we're framed up here, we're going to go ahead and get into the actual use of the laser tool here. Up on the top, we're going to go to Laser Tools, and we're going to go to Repeat Marking. So this is the utility that we're going to be using to actually effectively use the rotary jig. I'm using vectors here because that's just what I'm using. However, you can also use something like variable text or anything like that to mark multiples of what you may need to mark if you need to change names or do something in the project. You can absolutely utilize that. That's not really the subject for this video, so we're just going to stick to the basics here. So what we have here is this repeat marking. Now, if we go ahead and move the count, so the count is the quantity of items in the jig. So how many cutouts you have. It's not how many items you want to engrave, it's how many slots there are in the jig. So if I set the count to 3 and hit calculate, it's going to divide that value by 360 degrees from a full circle. So it's going to give you a step value or angle increment value of 120 degrees. That's not what we want because we have 4 cutouts. So this is where that angle value I discussed in the design phase could come in handy. So if you wanted to input that manually, you could. Lightburn, at least in its current form, does give you the availability to calculate the angle increment automatically by just setting the value here, but you need to use caution with that because if, for example, I only wanted to engrave 2 or 3 of these items, if I put 2 or 3 there and hit calculate, I'm going to get the wrong angle and it's going to miss every other item other than the first item that we engrave. At least it's not going to be aligned the way we want it to be. So this angle value needs to match what your jig is set up for. So in our case, it's 90 degrees, at least in our example. Some interesting things on this is you can set the count now that the angle increment is accurate. You can set that to, for example, 2 or 3 if you only had 2 or 3 items you wanted to engrave, or you could put 12, for example, if you were going to sit here and watch the jig, which you should be always present when a laser is running, but if you want to actively swap out engraved items on the jig as it rotates around to the next item, you could do that. Just be sure that you're utilizing safety equipment and make sure that you're not putting your hand under the laser for safety's sake. We want to operate these machines with safety in mind, so if you're going to do that, make sure that you design the jig large enough so that you can be nowhere near the laser while it's engraving. If you wanted to engrave 12, the rotary would rotate to each item on the jig in order, and then it would continue around the circle, a full circle 3 times to complete those 12 engraves. For our purposes today, we're going to stick with 4, but just to give you an idea of some of the utility as an example, you can really optimize your workflow. So what we're going to go ahead and do, I'm going to set this to 4. I'm going to turn my machine back on and we're going to hit start. Before we do that, let's go ahead and review the setup. So the setup is going to be very similar to your normal rotary setup. For now, we're sticking with rotating in terms of axis type, at least for this example. And primarily what we want to be looking at is steps per rotation. That's going to indicate, at least from software to laser, it's going to provide accurate instructions in order for it to know what to expect. So when we test this, it needs to rotate a full rotation in a circle. That means the starting point is also the ending point. Now, if we set this to 6400, for example, which is half of the steps per rotation that my driver is set to inside my machine, that is going to result in a very different outcome than 12,800, or similarly, 25,600. It'll either end too soon or too late. Similarly to that example, it's the same reason why you might try to engrave a circle and you might end up with an egg shape when you're using your rotary on a tumbler, for example. That is a major indication that your steps per rotation are set completely inaccurately. So you either need to make an adjustment. The 2 most common values that I see when helping others is 12,800 and 6,400, but by all means, it could be many values. It could be so very different from those 2 values. It entirely depends on the driver that's in your machine and how it's set up. This is one of those situations where you can absolutely test the steps per rotation, but if you're not getting an accurate result every time, that's an indicator that you need to double check what your driver is set to and make sure that matches what you're setting in software. So that said, my steps per rotation is set here and accurate, and the rest is more or less fine tuning. So min speed and max speed and acceleration all have to do with the speed in which that the rotary accelerates, the amount of torque it's able to apply, and the maximum speed that that torque will get you up to. You can turn these up or turn these down, but honestly, I leave these at the stock values. 500, 3000, and 100 are great starting values for me. The reason why I leave them at the defaults is because I don't want the rotary jig, or more particularly the motor that has a lot of torque behind it if it's turned up too high, I don't want it throwing items off of the jig, and I don't want it to cause a misalignment and ruin something on the jig. So while you can fine-tune this to improve speeds in which you're done with the job, the vast majority of the time isn't going to be spent rotating to the object. It's usually going to be spent engraving the item. So you can fine-tune this to min-max your time, but just be careful that you don't set these values too high and either lose product or hurt yourself, because this is a rotating item that's next to your laser and next to you. So just use caution with that. So we're going to go ahead and move on. I'm going to click OK. And this is ready to go. We're ready to frame it up one more time just to make sure we're good. And we're going to hit start. Now it's at this point that you can go ahead and swap out more if you want to and start it again, or change the design and run another 4. But that's kind of the general basics. If I wanted to run 2, let's say I was doing sets of 6, I could set 4 here and then change this to 2 and then run another 2. It's going to rotate in the same orientation. That's another option. Now that we're all set with using Lightburn here, we're going to go ahead and switch over to EasyCAD and show you some of the basics there and show you how to get basically the same results. Let's go ahead and swap over right now. Okay, so what we have here is EasyCAD 2. So you may not have seen this in a while, but it still exists. So what we have here is I went ahead and imported the design I wanted to use. I went ahead and hatched it like I normally do. And that's about it. Now, the only difference between the two in terms of utilities is this is more of an add-on rather than part of the program. So if you don't see this on your laser, we're going to be using Angle Rotate 2 to proceed. Again, if you don't see this, it may just not be included in your version of EasyCAD as an add-on, and you may need to grab another version. If this is a problem for you, go ahead and grab the community edition of EasyCAD 2 off of the website or off Discord. There's links to either in both locations. You can also go back to your manufacturer and ask them to provide you a version that this includes. There's lots of options, but in the interim, we're going to go ahead and proceed with Angle Rotate 2. I'm going to go ahead and turn the laser on so that it'll allow us into the tool here. So now with Rotate Angle Mark II open, we're going to identify a couple of similar features here. Now in Lightburn, we saw a start and end point, whereas here we're seeing 360 degree mark. So we want to make sure that's checked. We have Move Angle. That is the equivalent to the Lightburn angle increment or angle rotation per engrave. So 90 is what we're looking for there, and that is 360 degrees divided by 4 is 90. And the number here is the quantity of items we're marking. So how many times does it need to rotate and mark before it stops rotating and marking? So similar functionality to what we described in Lightburn. That's basically it. The remainder of the options here are light, mark, parameter, and quit. Light will highlight as per usual. Mark will mark as per usual. Parameter is going to give you your rotary setup, essentially. So same kind of things that we want to worry about when we were talking about the Lightburn values here. I'm leaving those as default as well. In my case, again, steps per rotation are already set, so we're already good there. And quit obviously closes the tool. So we don't want to do that. But we're going to go ahead and open this up and get started. One little tip here as well, when you're highlighting or red lighting your engrave in EasyCAD, you'll notice a lot of the time that it gets stuck in the screen where everything is grayed out. This is where you would utilize the escape key to back out of red lighting so you can get back to your tool. This is a common issue with Rotary Mark, and I kind of take it for granted a lot of the time, but I just wanted to bring that up as a tip as well. Alright guys, so we more or less talked about everything from jig creation and then also utilizing Lightburn as well as EasyCAD for rotary marking with the jig on your rotary for your galvo. I hope that really kind of helped cover and answer any of the questions that came up. I tried to incorporate some of the things that I missed in the live stream as well as incorporate some of the awesome feedback that I got from the community, and thanks to you guys for reaching out and saying this is really what you wanted to see. I'm sure we'll cover more jigs in the future, and I hope this kind of helps optimize some of your workflows. If you want to support the community and us doing these projects, check out Laser Master Academy. And if you have any questions or you're having trouble and you haven't joined any of our communities yet, check out the links to the Discord and Facebook groups in the description below. That's it for now, and we'll see you in the next one. Bye-bye.